This resource is the second in a two-part series on methods for solving quadratic equations. Part 1 defines quadratic equations. We then look at a general solving algorithm, supposing that the quadratic can be factored. We look at multiple examples. Part 2 considers the generic solution method for quadratic equations, the quadratic formula. The formula is presented. Then we consider multiple examples, including an application problem. What happens when we want to solve a quadratic equation that cannot be factored? We must use the all-powerful quadratic formula. To use the formula, the equation must be written in standard form: ax squared plus bx plus c equal to 0. The solutions for x are then equal to negative b plus or minus the square root of the quantity b squared minus 4 times a times c all over 2 times a. This formula looks very imposing. To use it, first we find our values for a, b, and c. We need to be very careful about minus signs. Then we plug those values into the formula. We do all the multiplications. Combine the numbers under the radical. Take the square root. Separate the solutions into the plus and minus cases. Simplify your answers. Let's take a look at the quadratic formula in action. Suppose we want to solve the equation for x squared plus 23x plus 15 equals 0. We may be able to factor this, but all that guessing and checking will take too long. Let's just use the quadratic formula. First, we need to identify our values for a, b, and c. A is 4, b is 23, and c is 15. We plug those values into the formula. We have negative 23 plus or minus the square root of the quantity 23 squared minus 4 times 15 all over 2 times 4. We do all the multiplication type operations. We are left with negative 23 plus or minus the square root of 529 minus 240 all over 8. Combining under the radical, we have negative 23 plus or minus the square root of 289 divided by 8. Taking the square root leaves negative 23 plus or minus 17 over 8. Split the plus and minus possibilities. Negative 23 plus 17 equals negative 6. Divided by 8 simplifies to negative 3/4. Negative 23 minus 17 is negative 40. Divided by 8 is negative 5. Let's look at another example to ensure we know how to use the formula. What if we have the equation 10x squared minus x minus 24 equals 0? In this example, our a is 10. Our b, the coefficient of the x term, is negative 1. C is the constant, which is negative 24. Plugging into the formula, we have x equals the opposite of negative 1 plus or minus the square root of the quantity, negative 1 squared minus 4 times 10 times negative 24, all divided by 2 times 10. Multiplying out, we have x equals 1 plus or minus the square root of 1 plus 960 divided by 20. Combining under the radical, we get 961. The square root equals 31, so we have x equals 1 plus or minus 31 over 20. Splitting into our plus and minus options, 1 plus 31 is 32, which divided by 20 simplifies to 8/5. 1 minus 31 equals negative 30, divided by 20 is negative 3/2. But why all this focus on solving quadratic equations anyway? Many real-world phenomena can be modeled using quadratic equations. Any projectile motion problem is in fact a quadratic equation. So any problem that involves gravity is really a quadratic equation, just waiting to happen. For example, when a shot put is released at an angle of 65 degrees, the height of the shot can be modeled by the equation negative 0.04x squared plus 2.1x plus 6.1, where x is the horizontal distance from the point of release. We want to find the total distance of the throw. Because we want to find the distance of the throw, we need to find out how far the shot travels when it hits the ground. When the ball is on the ground, its height above the ground is 0. So this problem asks us to set the equation equal to 0 and then solve for x. Inspecting our equation, we find that our values for a, b, and c are negative 0.04, 2.1, and 6.1 respectively. We plug those values into the quadratic formula. Do all the multiplication type operations. Combine the quantities under the radical. Take the square root. Now we split the equation into its plus and minus options and simplify. Looking at the plus option, we have the quantity negative 2.1 plus 2.321 divided by negative 0.08, which is negative 2.7625. For the minus option, we have the quantity negative 2.1 minus 2.321 divided by negative 0.08, which is 55.2625. Only the positive answer makes any sense. The negative option is what happens if the shot putter drops the ball and it goes backwards. The correct distance of the throw is a little bit more than 55 feet 3 inches. The quadratic formula is the default generic solution method for any quadratic equation. One reason it is so important to be able to solve quadratics is that they model any number of real-world phenomena, especially any projectile motion. Any problem that involves gravity is likely to be some form of quadratic equation. To use the formula, you must ensure that all the values are on one side of the equation with 0 on the other side. You then identify the a, b, and c as the coefficients of the squared, linear, and constant terms, respectively. Those values are entered into the formula. Work through all the multiplications, then combine the values under the radical. Take the square root, then simplify the solutions into the plus and minus options. Simplify, and you have found your answer.